Okay, another example. Here's an object that is released, is dropped. It falls 12 meters. How long does it take to fall 12 meters, and what's its velocity at 12 meters, all right, as it's falling, just before it hits anything, or while it's falling, what's its velocity at the 12-meter point? Okay, givens. Initial velocity is 0. Acceleration is negative g. And we know that it falls 12 meters, all right? Oopsies, make that negative 12 because it's downward. It ends up 12 meters below where it started. That's why that's negative. If you made that positive, you can't solve it. There's no way you can have just drop something and have it end up above it. It's just not going to happen. Not when it's being accelerated by gravity. So part A, we're looking for the time. The equation that has these 4 variables in it is the third one. Delta y equals v sub 0 y times t plus 1/2 ay t squared. Here's a situation where I want you to cross out this term before you start putting in numbers. It just is easy. You could solve it without it, but it's easier. To solve for t otherwise, you have t and t squared, you end up with a quadratic. And you'd have to use a quadratic formula to solve it. But we don't have to in this case because it simplifies. Since that goes to 0, why does it go to 0? Because the initial velocity is 0. It's the only time that works out. When the initial velocity is 0, 0 times t is 0. We end up with delta y equals 1/2 ay t squared. And now we can solve for t squared and take the square root of both sides. Again, if that didn't cross out, if the initial velocity weren't 0, you couldn't do that. You'd have to use a quadratic formula. So solving for t squared and taking the square root, the answer is going to be plus or minus, but the minus one makes no sense. We don't have negative times. That's going to be 2 delta y all over ay. You should never get a negative sign under the radical. We are not dealing with imaginary numbers in this class. That's 2 times negative 12, because it falls 12 meters, all over an acceleration of negative g, which is negative 9.8 meters per second squared. And that comes out to be 1.6 seconds. Again, these are rounded numbers because I'm paying attention to my significant digits. Okay. Let me just see what it really is because I already rounded it. So that's the square root of that divided by that. It's it's 1.56 seconds. But again, 2 significant digits. And then the last thing for this question is, what is the velocity? This is the easiest equation to use here. There are other equations. So that's going to be negative 9.8 times, and the actual time is 1.565. You can carry that out on my calculator. I'm not even rounding it. I'm carrying the entire thing out, and then I round my final answer to 2 significant digits. That would be plus 0. And let's multiply that out. So times that comes out to be 15.336. All right, so that it's negative. It's just 2 significant digits. Again, I am on my calculator, although this is 1.6, I entered in the original number on my calculator. Again, you only round your answer. That's negative 15 meters per second. The negative sign just means it's traveling downwards at that moment. Okay.